My name is Lexi Bader. I'm an intern at LREC, and I'm talking about richness of mammal species at the brush piles at LREC. And I'm looking at that in relation to coarse woody debris and pile location. I like to do presentations just a little special way. I was an RA in a past life, a resident assistant at a college, so I do fun presentations, I like to say. So in this corner up here is a rabbit symbol. That just indicates how far in the presentation that we are. Is going to move from left to right throughout the presentation. So that just indicates where we are in the presentation. So y'all can kind of keep track, be more engaged. This is where the slides are. If there's any images or any sources that I want to put in the bottom, they'll go right there. And this is my table of contents. So from slides 4 through 7, that'll be my background. 8 through 17 is my methods. 18 through 25 is the videos, and that'll be a little bit of an interactive portion for you guys, get to see some cool mammals. Results are 26 through 28, and discussion is 29 through 30. And this presentation ends at slide 33. And before we get too into the meat and potatoes of it, I wanted to talk about some terms that we'll be using throughout the presentation, just for your guys' knowledge. So the first is coarse woody debris, or CWD, and that is any woody debris that is greater or equal to 3-inch diameter. So about this. I guess I have a yardstick so I could show you, but about like this. And so that is any logs or big branches that you would see that is just scattered in the forest. And brush piles are essentially an accumulation of this woody debris that is into a pile. It doesn't have to be coarse woody debris, but it primarily is. There can be some fine woody debris in there as well. And we have a number of these on our property that I studied today. Abundance is how many individuals are in a species. So if you're studying squirrels and you set up a capture release and you find that there are 50 squirrels on the property, that is your species abundance. While species richness is you're looking at squirrels, you're looking at deer, even though there's 50 squirrels and 1 deer, that species richness is 2 because it's looking at the species themselves. So first, as a little bit of background, what do we do at LREC? And the first, very most obvious one is habitat restoration. We do a lot on this property. We do a lot of research, and we are bordered by neighboring lawn. So we have this really nice high quality woodland and prairie, but we have lawn or some lesser quality woodlands around us. And this can be really interesting because there are a lot of different mammals out there, and a lot of them have different habitat preferences. For example, deer prefer edgelands, which is in between 2 different habitat types. So the fact that we are bordered by lawn and then we go into woodland and whatnot, they may like that. And so that can be relevant to us. And secondly, in order to do this habitat restoration, we need to do prescribed burning on our property. And this is a way that we can bring a more natural ecosystem into our site, because prescribed burns are very important in making sure that we have as good of ecosystem services as we can, such as providing nutrient services or cutting down on woody resprouts and things like that that fire can provide. And in order to do this on our property, we need to remove the scattered brush that's around the property, because a lot of these coarse woody debris, 3 inches or longer, they will take a long time to burn and smolder. And with $1 million houses right next to us, we can't really do that. So in order for us to have a burn, we need to remove that and put it somewhere. And to do that, we form brush piles. And so we do our brush removal on site. And as an added benefit, this can provide habitat to mammals on our site as well. And so that's what I'm studying today. But why do we care? Why do we care about these mammals that are on our site or maintaining our brush piles and seeing what they can do? And at LREC, we manage our habitat. And part of that is making sure that we know what's using our brush piles on site and what may benefit them in the future. And so that's why I designed this study, to see how the brush piles are working, and what affects them, and how we can best support the mammals that are on the site. And the second is that, like I mentioned before, we're an edgeland site. So this can be really unique and relevant to a lot of animals, because specialists that need a big, high quality forest that's massive, thousands of acres, may not exist here. but some species may enjoy it here. And so brush piles tend to be most effective at edgelands, where you have a difference between one habitat versus another, because a lot of specialists may need that habitat that a brush pile can provide at an edgeland site. What's up? This is not a mink. I will get to that soon. I promise. Hold up, hold up. You have the whole slide. And before we get too much into that, what do other studies say? Because there are a lot of government sources or whatnot that are like, brush piles are great. But what do the hard facts say? And the first study that I looked at was Gogan et al. And this study looked at brush piles versus the presence and absence of brush piles and species abundance, so how many of each individual there was. And this found no correlation between abundance and brush piles. And this is interesting because this goes against a lot of things that we've been told. Brush piles are great and they provide habitat, but not always. And the study there said that a reason that this may have been is because there was too much coarse woody debris scattered throughout the property, that the ecosystem services that a brush pile would be able to provide was already provided by the coarse woody debris that was already there, to where they could hide around the nooks and crevices of the brush. And so study 2, which was Sullivan et al., and this studied 3 sites, 1, 2, 3. And at each of these 3 sites, they divided it into scattered woody debris, brush piles, and just old growth forest. And this showed that one of those sites had a higher species richness because specialist species that require a special type of habitat to survive preferred the brush piles. And so they increased at that site. And so that's really interesting because even though the doom and gloom of Gogan et al. Said that there was no benefit to brush piles, there can be depending on your site. And so this leads me into my hypothesis that brush piles will have a higher species richness if they're at the border of the property because of what I talked about with the edgelands. Maybe they might prefer the edge of our property where it goes from pristine grassland or woodland or whatnot into like a lawn or a lesser quality habitat, or if they have lower scattered coarse woody debris surrounding the pile to where they aren't reliant on those ecosystem services and would use the brush pile. And so these are my methods that I used. And this is my brush pile monitoring. This is what I calculated species richness with. And so 6 brush piles were selected, B1 through 4 and I1 through 2. You can kind of see my 6 brush piles that are on this site. So these red dots, B4, oh, that's touchscreen. So this is B1 through 4, and then more interior to the site is 1 and 2. And B means border, so this is within 75 feet of the property border, and the I brush piles are interior, so further than 75 feet from the property border. And I set up trail cameras at each of those 3 sites, or 6 sites, and took 10-second videos whenever there was motion detected. And I did this on 3 consecutive weekends because that's the time that there was the least property disturbance from humans on site. And I only counted a mammal as using the brush pile if it was recorded entering, leaving, scavenging in, or residing in the brush pile, because if a mammal just walks by, they're not using that brush pile. But if it's in any of those 4 categories, I counted it. And this was my coarse woody debris monitoring, which was a doozy. It took way longer than I thought. So because of this, I took data from 3 brush piles that were nearest to each other and assumed that a brush pile that was very near another one would have the same coarse woody debris. And I took the sampling method from Lutz and Keen, and you can see this right there. You start at the plot center, which for me was at the corner or edge of a brush pile, didn't count any of the coarse woody debris within the brush pile, and went due east and did 7 transects in like a hexagon. And what you do is you take like a caliper or something like this and just measure the diameter of that piece of coarse woody debris. And doing that, you add up all the diameters and you can calculate volume using the method in Baker-Chow. And that's how I calculated coarse woody debris. So we're going to get a little interactive here. What do you guys think was found in the brush piles from your knowledge? Not you, Akiva. Yeah. Bulls. Squirrels. Possums. Mice. Maybe. Mm-hmm. We did say mammals. Rabbits, yeah. Groundhogs. Plenty of groundhogs.
Skunks.
I did not see any skunks. Possums.
Snakes.
I did not see any snakes, surprisingly. Though maybe they just, yeah, they're not mammals. Any other takers? There were not any mink. Akiva.
But not since I was here. If I had to guess, I've seen something that you thought was a mink, but that turned out to be something different.
Yes. Do you remember the name of it?
Short-tailed weasel?
Yes. You spoiled it.
Lucky guess.
Any other takers before I continue? Awesome. So this is a section of the methods that I will go over all the species that I identified and how you can identify them. So all these pictures were taken from iNaturalist. And the first that I found was white-tailed deer. And these were found grazing around. Obviously, they can't fit in a brush pile, but they were grazing around it. And the scientific name is Otocoilus virginianus. So there will be a slight quiz at the end. I'll play some videos, and if you guys can like shout out what animal it is, you can go for it. If you know the scientific name, even better. And so these they have white on the throat, the face, the stomach, and the underside of the tail, which is why they're called a white-tailed deer. And you can pretty much always figure out what species it is from that. But if you find a buck that has the full antlers, it is non-branching. So it only has one piece of antler, it doesn't have another one that spikes out like this, which would be another species of deer.
Are there other species? Another species.
Yeah, we don't have any on our property, but if you're in another area of the US where they had different kinds of deer. Then we have the short-tailed weasel. We used to think that there were minks on our property, and there might be, but I think that what were minks, or what we thought were minks, were short-tailed weasels.
No, that tail doesn't look.
Really?
Yes, because I encountered one.
Oh, really?
And the minks don't have that white.
No. So the difference between a mink and a short-tailed weasel is that minks are about 3 times larger.
Yes.
And they do not have the white underbelly. But both of them have the long tubular bodies and the tail. But short-tailed weasels also have a black tip tail.
And I think since MSD, just for
That would make sense. Yeah, minks usually prefer like quality wetlands, while short-tailed weasels just kind of live anywhere. Then we have groundhogs, or Marmota monags. So there are lots of these. They are brownish gray. They have like a fluffy, rotund body. They're pretty wide around, and they have small ears and black eyes. Then we have the common raccoon, or Procyon lotor. And these have a black and gray banded tail. These are really easy because when you're looking at a trail camera, if you see it from behind or the front, they have pretty identifying characteristics, so you can pretty easily tell what it is. So from behind, they have the tail, and from the front, they have the black mask on their face. And their stomach and snout is like white to gray. Then we have the eastern cottontail, which is the rabbits that we have around here, or Sylviagus floridianus. And these have brown to gray fur and a white stomach. They have a white tail with brown fur on top, kind of puffy, and then they have long ears like a rabbit. We have the eastern gray squirrel, Sciurus carolinensis, and these are different from other squirrels that you might see. These are by far the most common squirrel that we have in Missouri, but you can tell because they're a little smaller than other squirrels you might see, and they're much more gray in the body. They might have a little bit of brown like on their arms or whatnot, but other squirrels will be much more red. And they have brown to gray fur with a white stomach and a long bushy brown to gray tail. We have finally, this is the last species that I found using the trail camera, the Virginia possum, and this is Didelphis virginiana. And these are also pretty easy to identify because they have identifying characteristics that can be told from the front or the back, depending on how you're seeing it on the trail camera. But they have the long pointed snout, they have a naked scaly tail, and they have long gray hair on the body with shorter white hair on the face. So we're going to watch a few videos. And if you guys are okay with it and you want to, feel free to yell out whatever species you think is on the trail video. If you can say the scientific name or part of it, great. If not, I don't blame you. It works.
Oh.
What is this? Yeah. We got here. Can you guys see the second one? Let me play that again. Yeah, you can see the second one right up there.
Oh,
So that was a family that I watched throughout all of my time studying this. And we got the common raccoon. Yeah.
So even though they don't live in the brush pile,
They just scavenge around it. Yeah.
That's part of it.
What's up?
I found a fawn in a brush pile a couple of years ago.
Oh, did you?
Yes, so they do use them.
Oh, wow. That's neat.
Just on the edge. with the arms
Yeah.
out.
That's neat. Yeah, they would scavenge a lot around the edges of it, but I could definitely see that as well. We got the white-tailed deer. Yeah. Any final guesses? That one was the groundhog. So you can tell because it's much wider than a weasel would be. So right there, it's pretty wide around. And it has like kind of like a bushier tail than a weasel would. This one was a little harder because you couldn't quite see its face. But yeah, that was a groundhog. This one's really neat. I love this one. Any guesses? I couldn't guess this when I first saw it. Let me play that again.
I didn't see a problem.
Yeah. Any guesses before I continue? Okay, do you want to say it, Akiva?
It's a possum carrying something that's dead.
Yes, I didn't know this until I started this presentation, but you can see right here, this where like there's like a bundle. Possums to build their nests will like wrap their tails around sticks and twigs and stuff and carry it to its nest. This wasn't the clearest video, but I thought it was a cool one. And so it's bringing it into the brush pile to build its nest. I'm not sure. I'm not good at aging. It looked pretty big. I don't know how fast they grow, but. Then we got this one. Do you remember the common name? Eastern cottontail. And then we got this one right here. It's a little sneaky. That's the short-tailed weasel. You can see how thin its body is compared to the groundhog. It does. It does. Yeah. Yeah. Perfect. Yep, the Eastern gray squirrel. And so that was what I got the joy to see every trail camera video. For every 10 that was just things flowing in the breeze, there was one that was really cool like that. And so this is the results for my species richness survey. I did 6 brush piles, and for a total whole site, you can see that at the bottom right there. And the highest like species richness for any brush pile was 6 species, and I saw 7 species throughout the whole survey. And this was my coarse woody debris results. So on this chart, I have species richness on the y-axis and coarse woody debris in feet cubed per feet squared on the bottom axis. And there was no statistical significant like correlation between coarse woody debris and species richness from what I studied.
Makes sense.
And this was my section for interior versus exterior brush piles. And this I also did not find a statistically significant difference. And I calculated that using a student's t-test. And so why did these results come out the way they did? And even though I didn't find a statistical significance, what does this say about our site? Because this is still science that can be used to make conjecture about our site. And so the first is the coarse woody debris and species richness correlation. And there was no significant relationship between these two, but why could this be? The first, less likely reason is that there's too much coarse woody debris on our site. However, whenever I was looking around, it did not look as though we had that much coarse woody debris, that those ecosystem services were just being used by the scattered coarse woody debris, and that none of them were being used by the brush piles. So the more likely reason is that we have too little coarse woody debris on our site to where most mammals just preferentially use the brush piles. And this makes sense because we are on a burn rotation and we constantly are picking up the coarse woody debris throughout our woodlands. And so it definitely makes sense if we just have too little coarse woody debris for us to be able to even have a trend line like that. And the second is interior versus border brush piles. So for interior brush piles, the average species richness was 4.5 species. And for border brush piles, they were also 4.5 species. So very clearly, there is no statistical difference between those. But what are the reasons for it? The first may be that 39 acres just isn't enough space on our property to be able to have a distinction between interior and exterior, because a lot of the mammals that we saw there aren't migratory, but they love to roam. And so a species that likes to stay in one place its whole life, it picks this brush pile and it stays there. We don't really have much of that. So that would make sense that 39 acres just wouldn't be enough to have a difference between all these types of species that we have. And the second is that maybe the species we have just don't have a preference between the edge of like a very well-maintained prairie woodland system and the interior of it. And the final one is that maybe there is a preference, but that is showcased by species abundance, the amount of individuals of that species, rather than species richness, to where you have a lot of individuals in one brush pile, but only one in the other, but you can't tell a difference with species richness. And there are some limitations of the study, as all good studies have. And the first is that, as I mentioned before, this is a species richness study, not a species abundance study. And you aren't able to tell species abundance through trail cameras. Because even though you're able to look at it and be like, oh, this looks like that baby deer I saw earlier, there's no way of guaranteeing. Because even though they might have similar markings, you can't tell individuals out that way, especially with like a groundhog where they all basically look the same. And so you can only get species richness from that instead of abundance. And abundance tends to be a stronger variable that you would have to design like a capture release study for. And the second is the trail camera mounting. I'm sure you guys could tell from the videos, but it was definitely very variable. The angle I got of the brush pile, or where, like, if there's any vegetation in the way or height or whatnot. So in the future, for future studies, I would definitely like get a rod or something and have a set height and distance away from the brush pile. And I thought these were cute videos and I wanted to show them to you. I saw some birds. Saw some deer. Saw an ant. This one, groundhog's right there. This one just had a bird right there. And yeah. That is the end of my presentation. Now questions. Yeah.
Okay, so at the beginning of your presentation, there were 2 studies that you looked at.
Yep.
What was the time frame for those studies? How much time did they use
Ooh.
to make their conclusion? It's okay, you don't have-
I don't have exact, but I remember looking at it and it was definitely over multiple seasons. I don't remember years, but I remember it was over multiple seasons that they sampled.
And your time frame, a month or 2?
10 weeks.
10 weeks.
Though 3 weeks, because that's when I actually went out and sampled.
Seems like you got
Yes, I only had on the weekends as well.
a lot of good information that even those other studies didn't have, or like the kind of they did theirs.
Thank you.
That's what it seemed to me.
Yeah.
Because that first study, it's like, it didn't have much
Yeah.
of species richness.
Yeah, it did not have species richness in that study. There was a lot of stuff that they went over because it was a huge forest in that study. So they had a lot of different stuff going on, but I picked out what was relevant for my study. Yeah.
Was it a, kind of a situation like ours, or was it?
I believe-
Or was it like wetlands or anything?
No, a lot of the studies kind of centering around what I am doing is forestry. And so it's a lot of like timber clear cutting companies researching the effects of clear cutting on mammals and stuff. So it's a little hard to like find directly relevant to like bottomland wetland 40-acre property things, but yeah. I thought whose hand did I? Okay.
But how do you know whether the animals are just checking out the brush pile versus living in it? I mean, did you assume that like the smaller animals are living in the brush, making their nests?
Yeah, so obviously if you see like a mammal exiting or leaving a brush pile, it's pretty easy to assume even if they aren't living in it, they're at least getting shelter from it because they're one of the best sources of shelter we have on the property. For animals that I saw just like kind of sniffing around it, I didn't assume that they was like living in it or utilizing the brush pile unless I like saw them like actively like nibbling on some like on the edge of it, like foraging or something like that. But I guess there's no way of telling if they like make full-time residence there, but at least they're benefiting from it by getting shelter.
And do you think that multiple species are living in one brush pile?
Yes. Or at least getting shelter from it because like the raccoons are most active at night. So I would see them like leave their den like at night and go and grab food or whatnot. So I could imagine that there'd probably, I can't make definite claims, but have like a primary like species that's using it, like those 2 raccoons that I saw, but other species are just popping in, popping out. But I'm not sure how they interact inside there. What's up?
Do you feel like your sampling method actually would find out if there were mice there or moles there? Because you weren't way down.
I was not.
So how do you feel like that?
I definitely thought about that because here, let me find where the brush piles are. Like definitely here, you can't really see like the bottom layer of it. So there's definitely mammals that I missed in this study. So that would be another interesting thing to go back and do. Get them a little closer, or a capture release study would be able to find them. Yes. So that's definitely a limitation to this. It's really the big charismatic animals I was able to capture.
The other question I had was about the squirrels.
Yeah.
Look, I never see squirrels here.
Yeah.
Here. I see the nuts they eat. Where did you see them? I mean, was
Um,
that a specific brush pile, or did you see them all the brush?
Ooh,
Go up to the glass house and see them burying
Yeah.
walnuts and all that else.
so this will tell you, I saw them at 3 brush piles, and primarily I saw the squirrels foraging around the brush piles. I don't think there were really any living in there, but I saw one kind of duck in, so I wasn't sure.
That's,
Yeah.
right? But-
Yeah.
Okay, I'll keep looking, the kids might talk about it. There are the squirrels, there should be
Yeah.
squirrels, and well, there's a nest up there,
Mhm.
obviously these ignorance, but I agree with them, there's squirrels.
Mhm. I think you, I'm sorry. I think you had the next question.
I was sort of surprised that the predators and prey were both, well, I guess the predator was going into
Yeah.
prey on it.
Yeah. Yeah.
Were there any snakes?
I did not see any snakes. I've seen a lot of snakes on like trees around here. I don't know if they're in the brush piles. I haven't seen any. Yeah.
Eventually we'll get it, we'll have an intern to crawl in there. She didn't want to do that.
Or one of the volunteers. Yes. Yeah, definitely. So that would be a good, interesting thing to do next, or within the brush pile even. Get fancy, but yeah.
So where were the ones with the 6, where were they located? Were they near further away from structures or closer to
Here.
water?
I can go back. Oh, this is way back. So this is where my 6 brush piles were. So they're pretty far away from structures, aside from maybe B4, which is like right next to the glass house.
So when I said 6, I meant the ones that had 6.
Oh, I see. That would be interesting to look at. I did not look at that. So we have what would be near structures, probably just B4 would be considered to be near structure, maybe I1. Yeah.
Water has any effect on the number of species.
That would definitely be interesting to look at. Yeah, I'd have to do an analysis on that.
I say that because I live next to a creek
Mm-hmm.
and I see so many.
Yeah. Yeah. That would definitely be interesting. One of the brush piles that I didn't study is pretty near-ish the creek, but because it's so close to the creek, it has a risk of being like washed away. So I didn't study it, but that would definitely be interesting too. Are there any other questions? Awesome.
Great, thank you.
Hi, everyone. I want to start by saying I do not have a little bunny at the top of the screen to track progress. I don't have slide numbers. I don't remember how many slides I have. So y'all don't know how long this could take. It could take 15 minutes, it could take an hour. I don't know either. I haven't done a full run through of it. So, I mean, we should be fine. I'm Akiva. My study is called Using Algal Surveys to Assess the Impact of Project Fair on Water Quality in Deer Creek. It's a bit of a mouthful. Really, with that name, I could probably just skip my whole introduction section, but I'm not going to do so. Okay, so introduction. So a bit of background. I'm sure a lot of y'all will know a decent bit of this, but there should be some interesting facts in here. So first off, Algal Surveys water quality. That's the whole basis of my study. So algal surveys, they're a bit of a newer, like not fundamentally new, but they're getting more popular as a technique for assessing water quality. Algae are useful for that because they are very diverse, very small, so they can grow close together. They're largely sessile, so they don't move around much. They're not gonna be running away. You don't need a trail camera. And they have short generation times, so they can respond very quickly to changes in water quality. So the use of algal surveys to test water quality, like I said, has increased in recent years, but because it still is a bit of a newer technique, oftentimes it's going to be cross-referenced with more established water quality surveying methods, like water chemistry and macroinvertebrate surveys, which we will do later on. And so just an example here of an algal survey technique, sort of, is Palmer's algal pollution index. which is from a 1969 study by Palmer, I don't know the first name, it's a rating system where different genera of algae are rated on a scale of 1 to 6, where 1 is the most sensitive to pollution and 6 is the least sensitive. We'll also get back to that later. So, Deer Creek. My study was in Deer Creek. Specifically, and this is very important, my study was based off of Katie's summer 2019 survey in Deer Creek. Same technique, same sites, all that. Because, spoiler alert, something big happened in those intervening years. But a bit of background on Deer Creek. So Deer Creek is a tributary of the River Des Peres. Its watershed spans roughly 37 square miles and it intersects 23 municipalities, because that's St. Louis for you. You can see, if you look at this map from the Deer Creek Watershed Alliance, you've got some watershed in Olivet, U City, Clayton, Brentwood, Ladue, obviously, Creve Coeur, all that. Big area, and a lot of that area, as you all know, is pretty built up. So across the watershed, there's an estimated imperviousness of 33%, as per the Missouri Department of Natural Resources. So a lot of runoff, and that runoff is going to be going into Deer Creek. So pollution in Deer Creek. Deer Creek has, for a very long time, faced problems with pollution. So for example, in 2020, it was listed on Missouri's Section 303D list of impaired bodies because of high chloride levels. And there's the runoff, but a big part of this is that older areas in St. Louis have for a very long time had a combined sewer system where both raw sewage and stormwater was going into the same system. And that system often wasn't big enough. And what that meant is when there was the sewer overflowed because of heavy rainfall, the sewage would go straight into Deer Creek. So here's a sort of related article from 1991. It's not the exact same thing, but this was a sewage pipe along Deer Creek broke, and a bunch of sewage poured into Deer Creek. And so there's big cleanup, sort of a scandal. Again, not the exact same thing, because this is not just like normal overflow, but it still shows sort of some of the limitations of the prior sewage system. So Project Clear was created to deal with this. It's a big project by the MSD, Metropolitan St. Louis Sewer District, to update the sewer system and, most importantly, separate these pipes and also give more storage capacity for water, so there's less likely to be overflow in the first place. So for Deer Creek, there's a bunch of different projects, but for Deer Creek specifically, downstream of Litzinger, there was a massive tunnel made, 19-foot diameter, called the Deer Creek Sanitary Tunnel. They had a giant tunnel borer you can see here, Mrs. Nancy. It's big. You can see this guy over here. That they used to dig this giant tunnel. That was, again, downstream of us, but on Litzinger grounds, there's a smaller tunnel that was built to replace the older sewer system. It's bigger than the older sewer system, has storage tanks, and that was constructed under the creek. And that construction went from September 2019, just a couple months after Katie finished her project, until August 2022. And there was a bunch of, it was a big thing. I'm sure plenty of y'all remember it. I'm not going to go into a bunch of detail, but yeah, big project. And it caused a lot of pollution, but it also did mean that the sewer system is separate now. It's not going to be overflowing. There's not going to be sewage overflowing into the creek. So, big question is that I'm going to be looking at is, has Project Clear resulted in a significant improvement in Deer Creek's water quality, specifically as indicated by its algal community? And my hypothesis would be yes, because there's not sewage overflow anymore. Seems straightforward enough, but we'll see. Methods. So, this is divided into 4 steps. First off, obviously, is collecting samples. So there were 6 sites where I collected samples. North Woods, the MSD Creek Crossing, Horse Trail, the Oxbow, the gravel road access, and then at Litzinger, like right around Litzinger Road Bridge. these were the same sites that Katie collected in 2019. But some of these were affected, obviously, by particularly heavily affected by the construction. MSD and gravel road access were like on the path, and so they're completely torn up. So I did sample from the same site, but you might expect to have a bit more change at those sites. In addition to Oxbow, in the time since 2019, the original Oxbow has become stagnant. It's a little stagnant, pond, and there's a new Oxbow. So when I was sampling, I sampled from both of them. And when I was sampling, I also focused on sampling the microbiomes that Katie surveyed in 2019, because her original study was focused on looking at differences between the microbiomes. And so I conveniently had a list of what she surveyed from, and I was able to collect from, epiphytic, epilithic, stagnant water, slow moving water, sediment, etc. And then, I collected the samples and I refrigerated them. And then I looked at them under a microscope. So I looked at two slides for each sample, just to try to make sure I'm seeing everything. And generally, I was looking at them, algae are small. I was looking at them at, 200 times or 400 times magnification. And for recording, recording what I saw, I photographed each type of algae, like if it looked visually distinct. I would take a picture of it and I would take notes on it. And then for mobile specimens, I also took video of their movements. And all this was for identification. I used the dichotomous key in Dillard's Common Freshwater Algae of the United States and Illustrated Key to the genera excluding the diatoms, another sort of mouthful of a name, to identify specimens. As you can see in the name, it's not looking at diatoms. Katie didn't look at diatoms in 2019. I didn't look at diatoms in 2024 because I didn't want to, and even if I did want to, it wouldn't help with anything because Katie didn't look at them in 2019. So there were a lot of diatoms. I'm sorry, I cannot tell you what they are, but we have some cool photos of them. And then I identified them. I posted the photos and my identifications on iNaturalist for feedback, and I feel like I need to give appreciation to two particular users, Roman Romanov and Some Plant, who helped me tremendously with this process. So yeah, 3 cheers for them. And also for identification, this right here is Casmerium, sort of looks like a brain. Finally, analysis. This is sort of a doozy. So I collected all the identifications from 2019 in 2024 in a spreadsheet. And so we'll see the graphs and tables. I graphed the number of sites that each genus appeared in, and I made a table of the number of genera from each algal class in each site. And then for a bit more data analysis, I conducted a Spearman's rank correlation coefficient, which I'll explain what that is, of the relative diversity / abundance of each class in 2019 and in 2024. So very quickly, just sort of side note, I say a diversity / abundance. My study is largely qualitative rather than quantitative because I was not recording the number of each genus I saw. That would not be practical at all. But because I had 6 sites, I did record each thing I saw in each site. So if there was something I saw in all 6 sites, I would consider that more abundant than if I only saw it in 1 site. And I use that for the Spearman's rank correlation coefficient test. And then also, very importantly, I mentioned this earlier, I also analyzed stream team data of water quality testing and macroinvertebrate surveys, both of which they're independent techniques for surveying water quality. So you can see here, you have the, one of the sheets for the different macroinvertebrates that we look at in stream team. So I was able to get access, very, big thanks to stream team for data going back to like 2000. I didn't use all of that, but I was able to compare that. And so I graphed that data, and I also conducted a Spearman's test for the macroinvertebrate data, compare, what existed, pre-project clear, post-project clear. Okay, so we're gonna get onto our results, but first, here's some cool things I saw. Here's Melissae varians. It's a diatom, so I didn't really need to identify it, but it looks cool. 400 times magnification. This was not algae or a diatom. It's family Actinophrida. Probably butchering that pronunciation, but I think it looks cool. It's got a bunch of things sticking out of it. Here we have on a Monactinus simplex. This was one of the algae that I reported. Just a pokey. Oh, I should also absolutely mention, big mistake on my part. Lexi helped me with this. Lexi helped collect the samples. Lexi helped with the identifications. Big thanks to Lexi. This is not my own effort. I did the data analysis. By myself, but Lexi helped. This is Lexi's photo here. Credit to Lexi. Anyway, so we have a Celastrum here. I think that also looks cool. Here are some of the big guns. Here's another Monactinus simplex. Look how big that one is. You got all those spikes on it. This is a diatom here, genus Gyrosigma. The only reason I know these genera is because I pushed them on Naturalist. And again, some plant, Roman Romanov, they came through and identified them for me. This thing was, I think that looks cool. You've got all these stripes in here. And then finally, this thing, Paramecium, you can see this is 200 times magnification, so this is pretty big. It's a ciliate. This thing was flying around. I was really trying to get a photo of it at 400 times magnification, but it was zooming around so fast I couldn't. Like, it was just too fast. And so I just barely managed to snap this photo. But this thing was zooming. And then also this. This is 100 times magnification. So keep in mind, this, scale-wise, this is 4 times as big as the other things we were seeing on earlier slides. This is a plant trichrome. I was going along at 400 times magnification. I stumbled across this kraken, and it looks pretty cool. I had no idea what I had found. I posted it on Naturalist and I think it's some form of life, and that I think that looks pretty cool. So enough fun. Here's the table.
Besides the aesthetics of these wonderful things, did you notice that the abundance of these, or the fact that they're there, that you found them, was that a good indicator of ecosystem services that they might provide? That having them in the stream was a good thing?
That's a good question, and probably would warrant an entirely separate study. I don't really have a good answer for that. Yeah, there were some other cool things. I found some, spores from some fungus, various other things. There's some cool stuff in Deer Creek if you look really, really, really closely. So anyway, back to our table. So, big table here. I'm not gonna ask y'all to, analyze all of it, but we will look at some things. I think some important things. You can see these are the classes that I saw of the algae. There were 7 total classes seen across both the years, and 6 seen in each year. So, and of what that means is that there were 5 classes observed in both years. So I'm not even going to try to pronounce this. This one and this one were only seen in 2024 and 2019 respectively, but all the rest were seen in both years. So, and over here you can see on this column I have for each site the number of genera seen across all classes, and then the total across all sites. And the green means that they're, it's the bigger of the two, more in that year. And as you can see, there were more total genera observed in 2019. There were 23 observed in 2019 versus only 20 in 2024. And across every single site, there were more genera seen in 2019 than 2024. So, something to ponder. In addition, so here's the genera graph. You can see each one. I have them color coded. Don't expect you to actually be able to look at this. It's fairly low quality and far away, but it's color coded based off of the different classes. 2019 versus 2024. So again, we can look at this. There were a total of 28 genera observed across both years. And of those 28 genera, 19 of them were seen at more sites in 2019, and 6 of them were seen at more sites in 2024. which is interesting, but I don't think that's that good of a data point because obviously some of them are going to be seen at more sites in one year than the other because they're only seen in that year. So I think a better way to look at it is there are 15 genera that were seen in both years. So, and of those 15 genera seen in both years, 11 of them were seen at more sites in 2019, and only one, which one? Oh, Celastrum, which we saw before, that was the only one that was seen more in 2024. So all that combined, I don't think, it's interesting. Did not go along with my hypothesis. So in addition, we have 3 genera that were the highest sensitivity on the Palmer's pollution index I mentioned before. So they were a 1. They're very sensitive to pollution. You expect to only find them in high quality water. That was Pandorina, Lepidosinclaus, and Formidium. Of those, Lepidosinclaus was only observed in 2024 at 1 site. So, I mean, that is a point towards 2024, whereas all 3 of them were observed. All 3 of them were observed in 2024. Only Pandorina and Formidium were observed in 2019. And so, yeah, more very pollution sensitive according to Palmer genera in 2024 than 2019. But that's where the abundance sort of comes in. That Lepidosinclaus is true, was only seen in 2024, but there was only 1 site that was seen at in 2024. Both Pandorina and Formidium were seen at more sites in 2019 than they were in 2024. Both of them were seen at 3 sites in 2019. Both of them were only seen at 1 site in 2024. So I think, can't conclude that much from this. Yeah, more total genera in 2024, more abundant in total in 2019. I think it's sort of, it's net neutral. But anyway, we'll get back to that. Here's another, I mentioned the Spearman's rank correlation coefficient. Let's go very briefly, very simply explain how this works. So it's not, so what it's comparing is the rankings of, in abundance or diversity of things, two different data sets from 2 different, in this case, time periods. So you would have 2019 and 2024 for each class. I did it based off of class, how much diversity / abundance there was for that class. What you do is you write it all out. So here, for example, we have these numbers in this example, and you would rank them, 1 to 7 in this case, since there are 7 of them, in terms of their number, how big they are. So for example, in this top set, there was only, 0 is the lowest, so it's 1. 4 is the second lowest, so it's 2. 6, there's 2 6s, so that'll be 3 and 4, so we average those, that'll be 3.5. Then 10 is 5, 11 is 6, 21 is 7. And then you do the same thing for the second data set, and you would have these. In this case, this is the algae data from 2019 at the top and 2024 on the bottom. And then you do this whole calculation. I'm not gonna really go through it. But where you would come up with this coefficient. You would have a number, and then you could compare the number to, at the statistical significance you're interested in, to the critical value, or you could, figure out what the statistical significance would have to be for it to be significant, what probability you're allowing. Anyway, the point is, long story short, the relative proportion and the / abundance of the different algal classes are significantly positively correlated. So there was a strong relationship between what was most common in 2019 and what was most common in 2024. It didn't change that much, which I think is interesting. It's not, Project Clear clearly didn't so thoroughly disrupt the algal community that the entire structure of it is completely flipped around. So now I mentioned the macroinvertebrate and water chemistry stuff. We can compare that. So far, quick break. So far, what I'm taking away from this, from the data from my algae stuff, is not that 2024 has a clearly, better water quality. If anything, I would say the opposite. But we don't have to look at that in isolation. We have the water chemistry and macroinvertebrate stuff. So here's the water chemistry. These are three things I selected, 3 tests that are regularly conducted here and also have clear guidelines as to what is healthy and unhealthy. So we have dissolved nitrate, nitrate, dissolved oxygen saturation, which is a percentage, and pH. And so we have the healthy ranges. For dissolved oxygen, it is greater than 60% saturation for like lowland streams like we have, as per the Missouri Department of Conservation. For pH, it's greater than 6.5 and less than 9. And for our nitrate, we don't actually have a, the Missouri Department of Conservation does not have a value, but the EPA recommends no more than 10 milligrams per liter for drinking water. And so we can plot, that area, the not safe area on the graphs, and you can see everything falls in. Nitrate, we don't even have a red area on the graph because our highest value is 1, and the highest value the EPA gives for drinking water is 10. We're clearly in the healthy range. And once again, you can see all of these. This is going back to 2018. They always fall in the healthy range. So we're also going to do macroinvertebrates. So I mentioned I did a Spearman's test for macroinvertebrates. Y'all remember how that worked, right? Okay. So long story short, I did one for both spring and summer, April 2018 versus April 2024, and June 2019 versus June 2024. And neither of them had a significant correlation. So algae did have a significant correlation. Macroinvertebrates didn't. The things that were most abundant in 2018 or 2019 were not the most abundant by the time we got to 2024, which is interesting. So I decided, let's try a different year. April 2009 to March 2012. It also did not have a significant correlation. So while we might have initially seen this and been like, oh, well, looks like, Project Clear really did a number on macroinvertebrates. No, it just, macroinvertebrate communities clearly have fairly decent turnover. And so we just don't have, can't really conclude anything from this. Project Clear Time, no significant correlation. Not Project Clear Time. As far as I'm aware, there was not anything big happening on the site between April 2009 and March 2012. Still no significant correlation. And so we can see this in this graph. Again, you have all the different things, all the different macroinvertebrates we looked at over here. Graphing there's the number of individuals recorded in each sampling time. And this is I'm specifically doing it in springtime because macroinvertebrates, there is phenology, they change throughout the year. So I'm controlling for time of year in order to make it be as consistent as possible. So you can see a bunch of different values, all these different trend lines, but because most of them hover in this lower range, you're below 50, and then you have a couple that are up at 200. This isn't really a great graph, so we can have it be logarithmic. And in this case, it's even crazier. You have all these values, all these crazy trend lines, really significant turnover as we saw with the Spearman's test. But how macroinvertebrates work is based off of what you see, you assign a water quality score. It's just a number. And here's that across that whole time. 2009 to 2024, what the water quality score was. It's pretty much the same across the entire time. So again, this is really, I want to drive this point home. The changes in community composition alone do not necessarily mean changes in water quality. Again, these things weren't even significantly correlated across these time periods. They were, look, let's go back for a second. Look at all these lines. You have midges that just drop off the face of the earth, and at the beginning of 2024, you have caddisflies that spring into existence in 2011, I guess. Some of these things are considered. Black flies did well throughout, but these values are not consistent at all in the slightest. Doesn't matter, consistent water quality based off of that data. So let's discuss that. I think that's a pretty interesting conclusion. So first question, do my data support the hypothesis? My data support the hypothesis that the water quality in Deer Creek will have improved since 2019. I sort of spoiled what I think, but let's look at the facts. More total genera observed in 2019 than in 2024. More genera observed at every site in 2019 than in 2024. More genera observed at more sites in 2019 versus 2024. And then we had the sort of a bit more ambiguous, high pollution sensitivity, more total genera, more total, as once again, specifically from Palmer's list, highly sensitive genera seen in 2024, but greater abundance of those genera in 2019. What do y'all think based off of this? This is interactive.
With their control for recent rains.
So I did the best I could. What I did is I did look at the USGS gauge on the bridge and made sure the water level at the time that I sampled, at the time that Katie sampled, was very similar. Neither of them were like actively flooding at the time that we sampled, but yeah, the water level was I think in both cases right around like 1.8 feet or so. I can't really I wasn't able to try to control that much for rain simply because I needed to sample at a specific time. So yes, that is a limitation, and we can go through some of the limitations. There is one overriding limitation that we'll get to, but yeah, I mean, controlled as best I could, consistent water level, but Susan suggested, yeah, algae could in fact, I don't know I have not done much research on the effects of rain, of flooding, what's washing away the algae.
So when it doesn't rain for 1 week, it's pretty low.
Yeah.
And scary. And then if it's like 2 weeks of no rain, it smells. But then after the rain, it's
Yeah. So given the water levels being consistent across both of them, I think that it's not like it was all stagnant in 2019 or anything like that. Again, the concern might just be that things I don't know to what extent algae that aren't epilithic or epiphytic might just get washed away and not appear in my sampling. Look, the fact that the Spearman test had a significant correlation between them, again, there was not that drastic of a change in composition and stuff between 2019 and 2024. We just saw more in 2019. But yeah, that is an interesting question. And again, something.
And
Yeah. So temperature, temperature, I didn't include it in my data, but we do have water quality, water temperature is part of the water chemistry data. So that was pretty consistent across those. And yeah, temperature, I believe I looked that up, was similar on the dates. Katie also collected over several days. I collected Lexi and I collected all our samples in 1 day. Katie collected over several days. And so, but again, both of those are very relevant things, and both of them would merit entirely separate studies, which I was not able to do based off of my time constraints. But yeah, that could definitely skew the data. Do you have a question?
Yeah, you have to finish the plan.
I mean, no, this is a good time. This is as good a time as any. I'm just
I'm just wondering if enough time has elapsed since the end of the
project. Yeah.
Right.
Yes.
To really have to see the difference.
So it's been roughly 2 years.
And upstream too?
Yeah, I believe I looked up, there was not, it's true, yeah, there could be a bit more happening upstream. I believe I looked up, there's not anything actively happening upstream. I think that is another fair point. But again, the water quality, the macroinvertebrates in water chemistry did not show a decrease in water quality that you might expect from active projects that are construction. Yeah, exactly. So again, we'll sort of get back to that momentarily, but that's true. Another limitation of it is that we don't know. I don't know exactly what's happening along upstream of our site along Deer Creek. Okay, so again, what do y'all think? Do you think that this supports that hypothesis that the water quality has improved since 2019?
Yes. Not based on your data.
Yeah, based on my data, I would say, I would agree, and no, I don't think so. Most factors are low, all the things highlighted in green are, are preferential towards 2019 versus 2024. Was that?
Look that, like, prior, the sewage and the water didn't make any difference.
So I wouldn't quite conclude that that didn't make any difference. The thing is that oftentimes this would be a, sort of like one-off event, sudden, overflow that would decrease the water quality and it would eventually recover. So it really just depends on, it was individual events and it has affected it in the past. But it is true that, yeah, for the most part, yeah, the water quality level was consistently good beforehand. It just, Project Clear, is not going to, it's just avoiding sort of catastrophic future events that might bring it down. In this case, you could almost view it, apart from the fact that there have been a few earlier events, you could almost view it as more preemptive for Deer Creek, specifically to avoid, an increasingly overloaded sewer system that is going to increasingly pollute the creek.
Something that the results say that the creek and the engineer and the creek are still in recovery from MST processing.
Yeah, so that's very much a possibility. I think it would be best, I'm gonna put on hold some of the comments until we get past my final slide. Because I do think some of these things will be addressed by some of my conclusions. But so yeah, I think the general consensus was that my data does not suggest an improvement in water quality. My data does not suggest an improvement in water quality since the beginning, since Project Clear, right? So how about the stream team data? Again, stream team data, all regularly measured water quality metrics fall in their healthy ranges since at least 2018. There was no significant correlation in macroinvertebrate community composition before and after Project Clear construction, but there was also no significant correlation during a completely unrelated, even shorter actually, time span. And there was no major change in water quality score based on the macroinvertebrate surveys since at least 2009. So what might we conclude from this? Like, what would this suggest in isolation? I would say, yeah, no change. It's pretty much, I have no major change. It's pretty much the same. Things are healthy. Water quality is pretty good. Nothing much has changed because of Project Clear. And so putting these together, what can we conclude? I don't think we can conclude that, putting them together, I would conclude that the water quality in Deer Creek does not seem to have improved since Project Clear. Like, water quality based off of the more established methods suggests no significant change. My tests suggested, if anything, a slight decline. There wasn't any evidence for an improvement. That might happen in the future. It might still be in recovery, but right now, no clear improvement. We can also conclude from the macroinvertebrate data specifically that significant changes in community composition do not necessarily correlate with significant changes in water quality. So that sort of casts the whole basis of my study into question, because clearly we can conclude things can switch around a lot without actually meaning worse water quality. And the macroinvertebrates showed that to us. But the big point I want to get to is we need more surveys to make any real conclusions, because we have two surveys, pre-Project Clear and post-Project Clear. That was the whole point of this study was that was a period where something big happened. But we don't have any basis for knowing what the normal behavior of the community is like. We don't have, as far as we know, nothing changed. The big change of Project Clear was just what normally happens. We wouldn't know that because we only have a sample size of 2. We can't conclude anything about extraordinary events before we understand what happens ordinarily. And so the final conclusion is that the LREC staff should force future summer interns to repeat what I did. Because yeah, we don't know. And that really, again, there's a lot of interesting hypotheticals that it might be in recovery, what the effects of Project Clear might have been. And my data actually could retroactively become, if we get a long-standing set of data under normal conditions that shows less of a change, then that could make my data a bit more conclusive. But again, sample size of 2, and between them, an extraordinary event happening, we can't really conclude anything about the ordinary behavior of the algae in the creek. So thank you for your time, and I'll take questions.
One of the big, I thought, arguments for this was the amount of E. coli that made it unsafe for swimming going in. Has that improved? Is anybody testing that?
I'm sure someone, like, there are some tests for that. That was sort of beyond the scope of my
So we
thing.
we probably do base, stream team does not test stream profile. But we do very basic water chemistry. I mean, the SLU water lab has been doing a lot of work here.
Occasionally they'll do E. coli, but they've done E. coli afterwards. Sometimes we can ask them to do it,
Yeah.
if they're doing. But
Wasn't that one of the big arguments?
Yeah, I mean, E. coli is like, if you find E. coli, there's poop in there somewhere. So I mean, we could potentially get some, I don't know how hard E. coli is to test for. Like, so we just, so do you want to do it?
Does the algae, type of algae, is it more prolific with E. coli or the type of microorganisms, can they be indication?
Yeah, so there's different genera can have different I mean, again, there's different pollution sensitivities. Generally, there are some types that thrive. A lot of cyanobacteria do well in more polluted water. Again, something that was like, there are a number of interesting things in my data that like would be interesting to research. For example, dinoflagellates, which Katie saw a decent number of, I saw none of. I don't know why, and I didn't really have time to figure out why beyond the scope of my study. But yeah, so looking more in depth on what things, which species are not just pollution tolerant, but like it's good for them, it gives them an advantage, would be really interesting. Although once again, you couldn't really compare the change in how common they are without having more surveys that sort of tell us how common they usually are with greater than one sample size. But yeah, there are different types that would benefit from lower water quality. A lot of those are bacteria. Part of the problem is that bacteria are even small, even tiny compared to algae. And so I was limited to a 400 times magnification. There were some things that I saw that probably weren't algae or may have been cyanobacteria that were literally just too small for me to like identify or take a picture of. But again, another one of the limitations.
So the other thing is the neighborhood, a lot of the neighborhoods along Deer Creek are very old and the pipes are really failed, over some of the pipes fail. So even though this project, the main pipe was replaced or installed, there could be constant failures upstream that is very hard for anyone to even know for a long time.
Yeah. So yeah, that's true. There's always going to be, again, at the beginning I sort of mentioned the imperviousness. There's a lot of runoff into Deer Creek. That's not going to be, entirely fixed by Project Clear because it's sort of beyond its scope. There will always be some pollution of Deer Creek, but I would like to emphasize that based off of the water chemistry and macroinvertebrate data alone, we do have good water quality. Like the pollution in Deer Creek is not, like I didn't have this in this presentation, but for the macroinvertebrate stuff, the range was pretty consistently right around 20. That's solidly in the good range that's assigned by the stream team, which I think is like 18 to 23, maybe 19 to 23. Like Deer Creek, somewhat surprisingly, based off of all the horror stories I'll read about, pollution in it, at least in our segment, does have pretty good water quality, but, even before Project Clear construction.
Well, methodology, should you do your samples, all in similar current and distance from the shore, or?
Oh yeah, so I sort of touched on it. But there were so when Katie was sampling in 2019, she collected from different microhabitats. She had a list of them. There was epilithics, growing on rocks, epiphytic, growing on growing on plants. Then there was stagnant water, slow moving water, fast moving water, sandy sediment, muddy sediment, etc. What I did is pretty much for each site, I sampled from as many of those as I could reach. So some of these sites, North Woods, for example, like it's pretty much just like a sheer muddy bank that Lexi sort of fell into. You know, we're gonna be like, so that one was more limited simply because it was hard, like you couldn't really get to some of the different things. In addition, it was just mud. There weren't like rocks you could scrape off or plants you could scrape off of. But whenever possible, I pretty much sampled from as wide a variety of like habitats as possible within that site. Any other questions?
What is Project Clear exactly? I didn't, maybe you said something about that. But
So basically, it's a project by the Metropolitan St. Louis Sewer District. They tout it as this big, we decided to improve things. They were sued by the EPA and were sort of forced to do it. But but the idea is improving the water quality and in particular dealing with the old combined sewer system that leads to pollution. So you'll see Project Clear things like all around. The new park in Brentwood, I think it's just called Brentwood Park. That park, has a big Project Clear, it's a Project Clear project to a large extent, like sort of building up the watershed. I've seen various houses around my neighborhood that have like Project Clear grants to make a rain garden. Like it's a big project, and Deer Creek is really just a small segment of it. And again, they look at this thing, like look at that guy, look at this thing. This is it's a big project, and it's ongoing. I think it started in like 2012 or something like that, or maybe that was when I was planned before then. Whole big thing, but fundamentally speaking, it's about improving water quality, in our sewer system in St. Louis.
They would replacing the smaller sewer pipes with much larger sewer pipes.
Yeah.
So that there would not be any overflow.
Yeah, so under Deer Creek, they replaced the old pipe, the old sewer pipe with a much bigger one, and also built like big storage containers for, for overflow capacity for heavy rainfall. So that like, again, the rainfall just isn't going to cause, it's much less likely to cause overflow.
And the manholes are not popping off. I mean, I live on old horse.
Did you try?
And in a flood, the manholes popped off and there was sewage. There was dry toilet paper when the flood came. And that same thing happened on LREC, right below the rain garden. And that's not happening anymore.
Yeah.
So it has, really helped that kind of thing.
Yeah, so look, honestly, entirely disregarding my data for a second, which I know is not good practice, but like, look, Project Clear, it had some, like it tore up a lot of the area here. We lost a lot of trees, a lot of, old prairie. It's definitely necessary. It's a net positive. It's done a lot of good things. And frankly, there's a very real chance that, yeah, it's just sort of, some of the water quality, things in the creek that over time the water quality will improve somewhat, even though it's already very good, because the gradual accumulation of pollution events won't be happening to the same extent anymore. But again, I just can't actually provide any hard data to back that up because my data did not back that up.
So what's happening with Project Clear is they're eliminating E. coli from getting into the, that's
Among other things, you get
among
sewage, yeah.
yeah, the sewage.
And
It's
for
keeping sewage out of the streams.
Yeah.
And out of your backyards and out of the municipal covers. But it's not keeping what could be coming downstream.
Yeah.
Or whatever that people are, that aren't very aware might be, putting down their drains.
Yeah.
You don't know what people are putting down their drains.
Yeah.
So it's like, how do you measure that?
Yeah.
I mean, you can measure the algae for your purposes or our purposes.
Yeah, and that's a bit more of the like purview of the water chemistry test for stream team,
Yeah,
like testing for fertilizers and stuff. Runoff, fertilizer runoff could be a big problem. Like and that would be the nitrate. Again, we're pretty good. We're pretty good in that regard. Yeah, look like,
Yeah,
but
we have limited parameters we can test for, because stream team made for non-scientists, basically, so it can't be too complicated. But then like, that's why it's useful to have people like this Clean Water Lab who, hopefully we get them to do a presentation for us. Because they've done some cool stuff, but they can test for a lot more things, and if they have indicators that will tell us if like municipal water is coming into the creek. Because there's one day, was it last year or this year, that the creek was like a weird color.
Yes, I saw
And
that.
we told them, and they sampled, and it's like, oh, there's a water main break. Because they flagged some like detergents or something.
Did you notice this past year, I think it was in 2024, there was a fish kill?
Yeah, I think that's the same.
Yeah, it was actually recently,
Yeah.
there were a bunch of dead fish this spring.
It was that, yeah, that's what I saw,
Yeah.
yeah.
Did we ever find out what caused that?
Well, you just said that it's probably a water main break.
Yeah, they have that same thing.
I believe-
Well, it was this year, I remember.
In the spring,
sometime in June.
Yeah, then there was like
I don't think that was it.
Yeah, no, I know. It is interesting. Sometime in June, when I was unfortunately gone, I was taking a couple of days off, but Lexi saw it. There was apparently like a big like bacterial bloom in the creek for like a day or two. That you had some photos, right? Or did Katie take photos? There was like a bunch of orange stuff.
It's only in a very specific area, so we're thinking it was something. Oh, I don't remember exactly, but we're thinking it was something from like the groundwater area or something. Can't remember what Katie said, but I don't, it was just in one specific area, I think it was.
So the algae that you study is good. Overly abundant.
Yeah, for the most part. I mean, again, my thing was mostly qualitative. I don't know what exactly would be considered too much, but yeah, for the most part, seems to be good in Deer Creek. And the dissolved oxygen, that would be, it's not anoxic. We have healthy levels of dissolved oxygen, so clearly the algae, isn't, it's not an algal bloom effect where it blooms, that dies, that decomposes, and sucks all the oxygen out of the water. So the water chemistry backs up the fact that we have a healthy amount of algae.
So the snail.
Yeah.
thank you.